McConley, and this is General Physics at Bernox-Westerlo. Today we're going to learn a little bit about accelerated motion. Accelerated meaning changing your velocity in a given amount of time. The way we're going to do it is we're going to drive an ATV between two fixed points that we marked previously, and if you watch the last video, those same 2 points. It's 60 meters apart, and we're going to calculate what is the acceleration of this particular ATV. So we're going to trade. I'm going to take the camera. I got a time of 6.7 seconds. So he's going to come back up and we're going to do a little calculating of the acceleration here. All right, nice job. So you came in at 6.7 seconds. Let's go over to the ATV here. Might come wrong on my left-hand side. So, accelerated motion, like we were saying, is a change in velocity. So the physics equation says that A, acceleration, is delta V over T. A being acceleration, I'll get to the units in a second. Velocity, and this is the delta meaning change in from math. The velocity is in meters per second. And we got time, which would be in seconds. So your acceleration then is a meter per second over a second. Kind of a mess, but the way we abbreviate that or break it down is meters per second squared. So it's how many meters per second you're covering. So that's your acceleration. So now let's look at our numbers. So, Assistant Andrew, how fast were you going when you crossed the finish line?
35.
35 miles per hour. Now, the problem with that, of course, this needs to be in meters per second. So we're going to have to spend just a second converting this, because this is miles per hour. And this is a good review on how to convert also. So we set up our parentheses, and we need to cancel out miles. So miles needs to go on the bottom so that they will cancel. And I'm going to put meters on the top. And I know that in 1 mile there are 1,600 meters. So that'll cancel our miles, leaving us with meters. Great. Now we just need to take care of our hours. So hours is on the bottom. We need to cancel that, bottom to top. Hours is going to go to minutes first. So in 1 hour there's 60 minutes. We're going to repeat that same process by taking our minutes, putting them on the top, so top to bottom cancellation, and changing that to seconds. So 1 minute being 60 seconds. All right, now a little bit of calculator work. I fire up the old TI-30XA, and we got 35 times 1,600 divided by 60 divided by 60, and we get that we are going 15.6 meters per second. Great. So now we know how fast we're going when we cross the line. 15.6 meters per second. But wait, was that the speed at the beginning? Definitely not. We started from a stop. Was that the speed at the end? No, I don't think so. Or was it? Yes, it was, because 35 was how fast we were going at the very end. So this is what we call a velocity final. Now back up to the equation. It said that acceleration is change in velocity. So really what that means in physics is it's the final velocity minus the initial velocity over the time change in. So I know that my final velocity is 15 2.6 meters per second. I know that in this case, my initial velocity was 0 as I started from rest, and it took us a time of, my time was 6.7 seconds. So now, again on our calculator, we can just take the 0, isn't going to make any difference here, so we're going to take the 15.6, we're going to divide by the 6.7, and we're going to find out that we have an acceleration of 2.3 meters per second squared. So let's put that into English. Here we go. You can face me with the camera now. What it means is that every second that four-wheeler was running between those 2 points, for every second that four-wheeler was running, we were speeding up 2.3 meters per second. So after 1 second, we were going 2.3. After 2 seconds, we were going 4.6, and etc. We were speeding up at that rate as we moved between those 2 points. Now, was our acceleration perfectly constant? Meaning, did we speed up the same amount as we went? Most likely not. But we're treating it as though we were, because I don't really have another way to figure it out without a radar gun where we could snap some actual velocities. So what accelerated motion shows us is how much something is speeding up over a given distance. So for today, this is Mr. McConley with BKW General Physics.